In this video, we will introduce you to SPH, Smooth Particle Hydrodynamics. The Smooth Particle Hydrodynamics, or SPH, is a Lagrangian method that captures the flow dynamics by discretizing the fluid into a set of fluid elements. Each SPH element has an associated mass, momentum, and energy. And these fluid elements move due to the interaction of other fluid elements, particles, boundaries, and body forces. The goal of the SPH method is to track fluid particles given it computes the interaction of the fluid elements against the boundaries, other fluid elements, and DEM particles. The fluid quantities are evaluated using a kernel function that interpolates the information from nearby fluid elements to provide smooth field for local variables. The information of a single SPH element has no meaning. You need to interpolate the information from nearby fluid elements to extract the information needed. Now let's get into SPH and DEM. Ansys Rocky's SPH approaches the interaction of fluid and boundaries by using a DEM-style interaction. The triangle-based approach is favorable for complex particle shapes, providing more accuracy between fluid elements and boundaries. When it comes to DEM interaction, Ansys Rocky SPH does not rely on closure models for modeling the fluid-particle interactions. It skips correlation-based approaches and instead a resolved mass is adopted for the momentum transfer. And it does this by placing SPH elements in the interior of each of the DEM particles. Each of these linked elements have an associated mass, and velocity is used to satisfy the no-slip condition at the particle surface. Given that DEM computes velocity, it also computes forces and moments applied to these interior SPH elements and transferred to the DEM particle. It's important to notice that this approach does have a main limitation, in which SPH elements must be smaller than DEM particles. When to consider a SPH-DEM simulation? When not only the fluid affect the particles but also when the particles affect the flow field. When there's a strong free surface flow. When there are large particles, which is an advantage over CFD-DEM coupling that may struggle with particles larger than mesh elements. And when it comes to post-processing capabilities, we have a couple of Ansys Rocky examples. In element tagging, you can analyze the fluid dynamics in critical areas of interest by tagging and tracking elements. In this dishwasher simulation, the SPH element tagging is used to optimize the spray arm nozzle design, and the shear stresses analysis offers a detailed assessment of cleaning performance. In Streamline's visualization, you get insights into flow behavior by visualizing and tracking fluid trajectories to uncover flow patterns, identify critical areas, and optimize designs. In this example, the streamlines are used to identify the water splashing pattern, and the cumulative wet time is to assess the water exposure in a car waiting simulation. And to finalize, here are some industry applications of SPH coupled with DEM. In the mining industry, or applications in surface interaction processes, such as wet milling, coating, and finishing. In landslides and shore protection, such as in wave breaker simulations. In the food industry, with processes such as heating, chilling, and washing, for example. To learn more about SPH, check out other Ansys Rocky videos and resources.